Wind blowing. The wind is carried by the air molecules, subjected to Coriolis force. The local wind blowing is similar to the cyclone as the air drift towards the right when they blew in northern hemisphere, thus towards left in the southern hemisphere. The deflection of the local wind is due to the apparent force due to the Earth rotation Coriolis force. Ship in the sea. Ship sailing on the sea is a good Coriolis force example. The ship appears as deviated from its path because of both water and wind. Both water and wind are affected by the Coriolis force. For all kinds of types of motion, we consider the Earth as a reference. When we observe the ship sailing on the sea from the seashore, it appears like they are tracing a curved path. This Coriolis force does not affect the mariners to sail, as the impact of Coriolis force is very much less compared to other forces acting on the ship. Firing bullet. After firing the bullet, it may slightly deviate from the target, thus, snipers are considered as Coriolis force example. Let us consider the example of military snipers. Imagine a lot of people surrounding the target. The snipers should be aware of the Coriolis force, otherwise, innocents will get hurt. If the sniper is shooting from a large distance, the trajectory of the bullet changes minutely due to Coriolis force. This affects the accuracy of the shooting. If the target is in the east, the bullet hits the target higher than he aimed. If the target is in the west of the firearm, the bullet hits the target lower than he aimed. This deviation is due to the Coriolis force. Draining bathtub. The Coriolis force also affects the draining bathtub water, but it is negligible because we are taking the Earth as our reference frame. Compared to the Earth, draining the bathtub is extremely small. The water swirls when draining from the bathtub due to the angular acceleration. The deflection of the water direction cannot be predicted in draining the water in the bathtub, and thus calculation is impossible. Though there will be Coriolis force acting in the process of draining in a negligible amount. Airplane. The pilots are highly aware of the Coriolis force in the airplane. Due to prevailing wind, the aircraft appears as they drift from their flight path, but they are actually in the right path. Another instance is that the airplane appears to trace the curved path even though they are moving in the straight path to the person observing the plane's flight path from the ground. Rockets. When the rocket is launched, we see the rocket begins to trace the curved trajectory. The rocket never traces the curved trajectory, but it appears like they are in a curved path. This apparent deflection, of course, is due to the effect of Coriolis force. The effect of Coriolis force on the airplane and rocket is very less, because the speed of the rocket and airplane is very much greater than the Coriolis force. Bounced ball. Suppose a ball is bouncing on the turntable of the carousel. At its edge appears to be in the straight line for the person observing the ball within the same frame, but for the person who is observing the ball from inertial frame sees the ball as the deviated from the place and is in the curved trajectory. This is due to the fictitious effect of the Coriolis force. Throwing the ball in the merry-go-round. Imagine that you are sitting on the merry-go-round, and your friend is sitting right opposite you on the same merry-go-round, and you throw a ball to your friend. The visualization of the looks, they have traced the curved path in the rotating frame. The appearance of the curved trajectory of the ball's motion is caused due to the Coriolis force. Ocean current. Ocean current is caused by the vertical and horizontal motion of the seawater influenced by gravity, wind, and water density. Due to the Earth's rotation and wind, the ocean current deflects the direction. In the northern hemisphere, the ocean current deflection is predicted towards the right, and in the southern hemisphere, the deflection is predicted towards the left. Trade wind. The wind blows from east to west near the equator. The trade wind is also referred to as the air currents. This type of wind blew westwards due to Coriolis force. The air traces the curved path and rotates in counterclockwise direction northern hemisphere and thus clockwise in the southern hemisphere, and hence in both the hemispheres, trade wind blows from east to west. Clay pot making. The clay pot maker should be aware of the Coriolis force as the pot is done by rotating the pottery wheel. The pot maker is in the inertial frame, thus, he may see the drift while making the pot. Driving the car in the curved road. While driving in the car in the curves, the passengers move towards the left if the car is turned towards the right. The fictitious force is acting on the passengers. In the curved path, the Coriolis force exists. The person observing the car's motion sees the car has bent towards the surface. This apparent deflection of the appearance of the car is due to the Coriolis effect. Tornadoes. The insect's flight is largely affected by the Coriolis force. The effect of Coriolis force on insects? Force is due to the linear motion of the appendages, which is capable of detecting the rotator motion. Insects are provided with the dumbbell-shaped organ called a halter. The halter oscillates with the frequency same as the main wing so that the body of the insects rotates, resulting in the deviation of the halters from the plane. Tornadoes. The swirling of the tornadoes makes the rotation motion. The Coriolis force indirectly influences the tornadoes. Tornadoes are too small initially and tend towards the general direction of low pressure. In the northern hemisphere, swirling of the tornadoes is anti-clockwise, and in southern hemisphere, the swirling is in clockwise rotation. The apparent deflection of the tornadoes thus takes place in the right side when it is observed in the northern hemisphere and hence left in the southern hemisphere. Frequently asked questions. What do you mean by Coriolis force? Coriolis force is an apparent force that can be described in terms of frame of reference. An inertial force that exerted on the rotating object with respect to an observer observing from an inertial frame. In the clockwise rotation, the Coriolis force acts towards the left, and the Coriolis force acts towards the right in the counterclockwise rotation. Does Coriolis force is constant everywhere on the Earth's surface? No, the Coriolis force is not constant, it varies on the Earth's surface. The Coriolis force is maximum at the two poles of the Earth's surface, and along the equator, the Coriolis force is absent. Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. Scientific calculator and many more other tools.